Hello students, welcome to the lecture on integrity constraints, and after this lecture we will be able to learn the following objectives. Understand the concept of integrity constraints, discuss about multiple constraints, describe the entity integrity, explain update operations on relations, and explain domain constraints. Let us start with accessing database. We know that unauthorized users can access the database. They can damage data in the database. Also, they can make the database inconsistent. Also, a normal DBMS user can make the database in an inconsistent state because of accident. So, some restrictions should be made in the database so that the users do not make changes to data accidentally. Integrity constraints are intended for the normal user. These integrity constraints ensure that changes made to the database by authorized users do not result in a loss of data consistency.
A simple look at the data in our state list table shows us we have 53 records, and all states and territories listed of importance have values for the state ID field, the state name field, the region name field, and the landmass field. Now, when we look at the metadata of this table, what we see is that it has no keys and it has no indexes. So how is this going to affect what we're going to do next? Well, let's take a closer look at this data and notice we have a mistake. Colorado is abbreviated as CO and Connecticut is abbreviated as a CO. It allowed that even though Connecticut should have been a CT. There are no key constraints preventing duplicate records from being entered into this table. Another thing you may notice is when we get down to NH for New Hampshire, we have the entire record listed twice. It's a total duplicate. So it's probably time to scrub this data. And after we scrub the data, we want to make sure we don't allow duplicates in again. Let's fix the CO Colorado Connecticut problem first. Type update state list, and we're going to set the state ID equal to CT, where the state name is equal to Connecticut. Let's select this query and then run it. Okay, that fixes one of our two data impurities, but how about the New Hampshire duplicate? How do we get rid of just one of those records? Simply type delete top 1 from state list where state ID equals NH in single quotes. Run the delete statement. To check to see if we've gotten rid of our duplicates, let's run a select query. We can see that Colorado and Connecticut each have their own state ID. And we only have one New Hampshire. And we're down to 52 records because we got rid of one duplicate record. Okay, let's put a primary key on the state ID field of the state list table to make sure SQL will not allow any accidental or intentional duplications. Let's type alter table state list, and we're going to add the constraint, and we'll call it PK for primary key, underscore the name of the table, state list, underscore the name of the field, state ID. What type of constraint is this? A primary key, and we'll leave it as clustered. And we will set the state ID to be in ascending order. Let's run this. And let's expand our tables and take a look to see what we've done. In the Object Explorer in JProCo under the state list table, refresh your keys folder and notice the creation of this new primary key. Also refresh the indexes folder, and it looks like we have a new index. We have an index named after the primary key, and it's set as clustered. Well, let's see if this really protects us. Let's attempt to update the state list table, and we're going to try to set Connecticut back to CO. Update state list and set the ID to CO where the state name is Connecticut. Okay, let's see what happens now. It says violation of the primary key. You cannot insert a duplicate key into state list if they have the same state ID. Okay, so is all well in our state list table? Okay, well, it looks like our Colorado, Connecticut thing's resolved. Everything looks pretty good. Wait a minute. The District of Columbia has 68 square miles of landmass. How can it have a negative number? Looks like a few negative numbers got slipped in there. I don't know exactly how many. Oh, here's another one. So what I'm going to do is just say, hey, the numbers are right. They just have a negative in front of them in a few situations. Let's go ahead and update the table to flip the negative back to positive if it's below 0. So we're going to set the landmass equal to landmass times -1, where the current landmass happens to be less than 0. Run the update statement. Wow, 4 rows have been updated. In querying the table, it looks like we have all positive numbers for landmass. Well, it would be easy for somebody to update or insert a new record with a negative number. So we're going to add what's known as a check constraint, and it's going to check to make sure the number's positive before adding it in. Let's write alter table date list, and we're going to add a constraint called CK for check state list, and we will check the landmass. Now we're going to check it to make sure that the landmass is indeed greater than or equal to 0. Run the alter table statement. This command's completed successfully. Now, any DML statement that tries to put negative values in the landmass field should fail. Let's run this update statement that should try to update many landmass values to negative numbers. That statement that causes those negative numbers, that's not going to work with this check constraint in place. So our update statement scrubbed our data and made sure all the numbers were positive, and the check constraint ensured no negative numbers will start coming in. Again, let's look at our state list table. Notice everything's pretty good. Alaska's our biggest state. It's got about 600,000 square miles of landmass, and DC's the smallest with 68. Well, let's look at the check constraint that we just made. Let's expand constraints, and notice here is our check constraint. Now this prevents the numbers from getting too small. Okay, well what about a mistake in the other direction? For example, let's say somebody entered the landmass for Alaska, and they had the numbers right, but they were entering square meters or square feet accidentally. So they put 65 million square miles. Now, there isn't even 65 million square miles in the whole world, so I'm pretty sure Alaska can't be that big. If you were to run this update statement that puts 65 million landmass in for Alaska, it would accept it. Is Alaska really bigger than the planet? I don't think so. So let's update this and fix this back, and make our check constraint just a little bit more robust. Type alter table state list, and we're going to add a constraint called check state list landmass. Wait a minute. We already have one called check state list landmass. We won't be able to create that unless we get rid of it first. But let's finish our logic. We will say landmass has got to be at least 0, but it can't be larger than the entire United States, which is just over 2 million. Delete the original CK underscore stateless underscore landmass constraint and recreate it with this new code. Now let's go and try to make Alaska ridiculously large. And it says, hey, I'm sorry, I checked and you are not between the acceptable ranges. You've got to enter a valid number. And there we go. It protected our data based on what we specified as the logic in the check constraint.
Integrity constraints. Integrity constraints provide a way of ensuring that changes made to the database by authorized users do not result in a loss of data consistency. Stipulation that certain attributes form a candidate key for the entity set. Mapping cardinalities L1, L, many and many, many. We know that an attribute has a set of possible values associated with it. For example, in the student table, student, student ID, name, marks. We know that the set of possible values for the attribute student ID is in the range of integers. For attribute name, the set of possible values are a group of characters. For attribute marks, the set of possible values are integers. So these integer, character, data, etc. are called standard domain types. A set of attributes should be unique in a table. A primary key is a column or combination of columns that has the same properties as a unique constraint. Because the primary key is used to identify a row in a table, it must be unique and must have the not null attribute. A table cannot have more than one primary key, but it can have multiple unique keys. Primary keys are optional and can be defined when a table is created or altered. They are also beneficial because they order the data when data is exported or reorganized, also known as referential constraints or referential integrity constraints, enable us to define required relationships between and within tables. For example, a typical foreign key constraint might state that every employee in the employee table must be a member of an existing department as defined in the department table. The database manager handles these types of situations by enforcing a set of rules that are associated with each referential constraint. An insert operation could attempt to add a row of data to a child table that has a value in its foreign key columns that does not match a value in the corresponding parent table's parent key. An update operation could attempt to change the value in a child table's foreign key columns to a value that has no matching value in the corresponding parent table's parent key. A delete operation could attempt to remove a record from a parent table that has a matching value in a child table's foreign key columns. Entity integrity ensures that there are no duplicate records within the table and that the field that identifies each record within the table is unique and never null. Entity integrity specifies that the primary keys on every instance of an entity must be kept, must be unique, and must have values other than null. The primary key for a row is unique. It does not match the primary key of any other row in the table. The primary key is not null. No component of the primary key may be set to null. An attribute can have more than one constraint defined for it. Any data inserted into the table must satisfy all the constraints defined for an attribute. Update operations on relations. The original relational database is considered the view on the migrated OODB. Update operations submitted against the original relational database should be translated into equivalent operations on the OODB. Insert, update, searched, delete, searched. Translating a relational update statement consists of locating the objects to be manipulated, except insert, checking the integrity constraint. Given a relational insert operation which supplies a set of attribute values for a new tuple. Insert into R, column, comma, list, values, value, comma, list. The SQL standard provides positioned delete, which deletes the row pointed to by the current cursor point, or a searched update, which may result in the deletion of several rows. We will focus on the deletion of a single tuple, which takes the form delete from R in bracket R, where k is equal to A, where k is the primary key of R and A is a valid value in k's domain. We consider an update operation which sets attribute P of the tuple T identified by the primary key value as the new value VAL. Update R, set P is equal to VAL, where k is equal to A, where R is equal to k union F union A. If P epsilon A, then setting P to A new value won't violate primary key and foreign key constraints, and on the OO side involves only locating and setting the piece of data to the new value. If P epsilon K or P epsilon F, setting up a new value, must first check against the primary key and foreign key constraints and may change the relationship between objects or even cause object migration.
Y usaremos de ejemplo nuestra base de datos Norwin. Utilizaremos la tabla Customers. Ahora nosotros necesitamos insertarle datos a esta tabla. Para insertarle datos, utilizamos el comando insert con la palabra into. Luego de indicarle que queremos insertarle a la tabla, debemos de enunciar los campos de esta tabla. Al momento de crear la tabla, se especificó qué columnas podían dejarse en blanco y qué columnas no podían dejarse en blanco, así como los valores predeterminados de las columnas. Por lo que, al momento de insertar datos, puedo omitir las columnas donde no es obligatorio insertar un dato. Pero, si omito una de las columnas donde sí es obligatorio llenar un dato, al momento de efectuar la inserción devolverá un error. Luego de las columnas escribo la palabra values y ahora entre paréntesis agrego los valores que deseo insertar a las columnas respectivamente. Los datos insertados deben de coincidir conforme los nombré en la instrucción, aunque no sea el mismo orden que el que esté en la tabla. Agregaremos ahora el nombre de la compañía, el nombre del contacto, y el país. Para esto vamos a cerrar el explorador de objetos y ahora ejecutamos. Marcamos nuestro insert y presionamos ejecutar. Nos dice que ya insertó el dato y para eso no tenemos nada más que consultar la tabla Customers. Donde podemos apreciar el dato insertado. Las columnas que no agregamos en el insert reciben un valor nulo. Otra forma de insertar datos en bloque es insertar toda una instrucción select a una tabla. Como no tenemos para nuestro ejemplo una tabla que se preste para esto, crearemos una. Listo, ejecutaremos la instrucción y presionaremos ejecutar. La tabla se ha creado y si ahora consultamos la tabla, obviamente no tiene ningún dato, pero enseguida los tendrá cuando hagamos un insert into clientes, y para hacer la inserción en bloque no colocamos la instrucción value, sino directamente hacemos el select customer ID, company name, contact name, country from customers. Debemos de tener en cuenta que para esto la consulta que necesitamos insertar debe de coincidir en cuanto a campos perfectamente con la tabla donde voy a insertar el dato. Lo seleccionamos y ejecutamos y se han insertado 92 filas. Consultamos ahora la tabla clientes y tiene los datos provenientes de la tabla customer. Otra instrucción relacionada con la inserción de datos, pero esta vez permite crear un nuevo objeto, es decir, permite crear una nueva tabla a partir de una consulta que fabriquemos, es la instrucción into.
Assertions.
There are 4 commands in SQL data manipulation language. Select, which is for data retrieval, followed by insert, update, and delete. Insert allowed us to add a new record in a database table. Update allowed us to modify existing data in a database record. Delete allowed us to remove a record or records from a database table. So let's look at the insert statement. You can insert into a table and you can list the column from the table and then define the value which will be used to assign to the corresponding column. And in this case, we're insert into division table. We're not listing a list of column name within the division table. In this case, we'll assume the first value would be the first column inside the division table. In this case, I know it's division ID. The second column in this division table is director's employee ID, and the third column is the division's name, in this case administration. And you may notice that the value for a string column data type should be enclosed in single quote. The director's ID is a number, so we don't need to enclose it in single quote. And let's look at this example. I'm insert into the division table and its division name and division ID, where the values of division name is RND and the value of DID is D070. Okay, let's take a look in Access how we can execute this insert statement. I'm going to copy it. I'm going to use Access, bring up Access. So in Access, I'm going to say create. Query design. I'm going to close this show table. Let me expand this a little bit. I'm going to choose append, which really means insert in a record into the database. You choose the table where you want to insert a record into, in this case division. So once that has been chosen, you don't see it here, you don't have a visual cue here, and you want to say, okay, I want to insert something into division ID, a record with a division ID, a division name. I also want to have assign a value to the division ID. So in this case, you can this value field, this row called field in this case, should be where you set the value. For instance, you can say single quote R and D, and the division ID you can enclose in single quote and say D0. Let's use 70, and then we're done. Okay, so basically we're assigned the R&D as the division name. We're assigned D070 as a division ID for new record to be inserted into the division table. So let's run it. And they say, are you going to append a row? We're going to say yes. Once that's done, if we go to division, we find out that record has been inserted. We did not insert any value to the director's column, so this is empty or null. So this is how you actually create an insert statement. So we can kind of come here and close it. It's not saving it. Let's come back and look at the update statement. Update statement allow you to change the data in an existing record or records. For instance, here I want to update the instructor table. I want to set the last name to when only for the record where its instructor number is 21. This equal sign is an assignment statement. You're assigning this value when on the right hand side to the column name at the left hand side. Here this equal sign means equal, which means instructor number equal to 21. So this update statement together really means I want to change employee number 21's last name to when and nobody else. Okay. So let me copy this. In the we're going to try to play with the update function. It's still a query, and we're just going to close it. That's a SQL view. If you do this, that's the update statement. Okay, let's first look at the instructors table. I have instructor number 21, it's called Bruce Smith. And then we're going to change the last name to when. So we're going to change employee number 21's last name to when in quotation. Instructor number is a number, so we don't need quotation. So let's take a look. Let's go to query. Okay, you switch to the query design view, query and design view, and then if you say run, the system is going to update a particular row. I'm going to say yes, go ahead and do it. If you go back to the table, go to instructor, now you find out employee 21's last name has been changed to when. Okay. So the update has been accomplished properly. You can save certainly this update statement. You're going to let me just say update last name of employee 21 to when. So that's the query. You say update last name of employee. So you can actually bring this back. Usually you want to say open in the design view. If you look at the design view, this may not make a lot of sense to you. I would suggest you, if you do insert, update, delete, use the SQL view. It's much easier. Okay, but let's try to do it in under the design view. Query design. Let's not choosing any table. So I'm going to say close. We're going to choose update. Let me backtrack. We go to show table and we say we want instructor table, and then we're going to choose the instructor table, and we're going to say I want the, let's say, the last name. Let me change the last name back to Smith in single quote, and then I want the instructor number to be equal to 21. So that's actually the criteria. I want the instructor number 21's last name to change back to Smith. Okay, so let's run it. Say you're about to update one row. Then I'm going to say yes, go ahead and do it. Let's see when that has been done. We come to table and we choose instructor. So now employee number 21's last name has been changed to Smith. Okay. Let's go back and quickly look at the syntax here. Okay, that's exactly what we have been doing. This update statement means that we want to actually change the salary of all the we want to update the salary of all the instructors in division, where means in divisions D010s, to be 10% more than their original salary, which means you give everybody in division D010 a 10% increase of their current salary. In this case, the update statement may impact multiple row or multiple column. For delete, the syntax is very similar to the update. And you say, I want to delete from the instructors table the employee number 52. Then you're deleting a particular record. If you say I want to delete from the student table where the telephone number like 301. This in excess, this should be asterisk. In this case, it means that you want to delete all the students whose telephone number started with 301 area code. If you just say delete from division, then you're removing all the existing records in the division table. You are not removing the table itself. It will become an empty table. So this concludes our review of insert, update, and delete statement in SQL relational database, and how you use the access sample database to perform those three operations.
An assertion is a predicate expressing a condition we wish the database to always satisfy. Domain constraints, functional dependency, and referential integrity are special forms of assertion where a constraint cannot be expressed in these forms. Ensuring the sum of loan amounts for each branch is less than the sum of all account balances at the branch. Ensuring every loan customer keeps a minimum of $1,000 in an account. When an assertion is created, the system tests it for validity. If the assertion is valid, any further modification to the database is allowed only if it does not cause that assertion to be violated. This testing may result in significant overhead if the assertions are complex. Because of this, assert should be used with great care. Some system developer omits support for general assertions or provides specialized form of assertions that are easier to test. Triggers. Several existing systems have their own non-standard trigger features. A trigger is a statement that is automatically executed by the system as a side effect of a modification to the database. We need to specify the conditions under which the trigger is executed, specify the actions to be taken by the trigger.
Notice that in this example, we only really care about the city column. We're just saying, hey, if the city can be null or it has to be distinct, either one. Okay, but there's an operation we could do here. Let's select splat from representatives. Or say somebody gets married, Susie Smith gets married, and so we need to update Susie's record. We say update representatives set last name equal to, I don't know, say she marries a Jones, where ID equals 2. Okay, so that would update Susie's last name to Jones. But if we're doing a lot of updates and things like that, look at what's going on here. We're affecting the last name column. Okay, we're not even touching the city column. However, when I do this update, I said we need to run this trigger on an update. So this check will still execute, which in this case, on one record, not a big deal. But if we were doing millions of records, I don't know, say we're Amazon or whatever, some big site, and people are changing their names all the time or changing other stuff that's causing triggers to fire. Well, we don't really want to have to do this select, this group by, this count, all this work, unless it's absolutely necessary. And it's only absolutely necessary in the case where the city column has changed. In this case, we're not changing the city, but yet all this work's still going to be done. So there's one way we can get around it. We can say if update, and update is a function here that it exists in the context of a trigger. I can say, hey, if they updated this city column, then begin, and notice these begins and ends get a little clunky after you have a bunch of them in here, but begin and if they updated the city column, then let's go ahead and do all this work because we need to make sure that we don't have a duplicate city. Well, otherwise just skip it and let's just get out of here. Let's not waste our time. So let me just comment this out for a minute. In fact, I want to get my inserts back. So don't blink. Let me get the inserts back. Okay, so now I have my inserts, and just to show you that this if actually does work, I'm going to say print running the check. Okay. ... All right. So if we don't see this print, then we know that we didn't do all this work. So So let's run all this thing. Instead of doing this update, I'm going to comment the update out for now. So here we go. Create the table, create the trigger, but if they didn't update the city, then don't do all this work, and then insert into all this. So run it and we see running the check. One row is affected, running the check, running the check. All these inserts, they did update the city column. I mean, it's really an insert, but if an insert is an update in a way. Basically, we're changing the value. There's a potential that we updated it. So notice that there's not a separate insert function. Insert is a keyword. That's why it's showing up in blue when we've used that word several times. But there's an update function. And so we did update the city, we did update the city, we did update the city. So that's why we get running the check. Let me just drag this up so you can see all the output. It ran the check for all three of those inserts. Okay. But now let's do this update and only touch the last name. We're not going to touch the city column. So run this by itself. Notice there's not running the check going on. The trigger's still fired, but the check, we didn't update the city, so we skipped all this work. And that's nice. Oops. That's nice. It's an optimization. So anyway, keep this update function in mind. You don't want to make your database do more work than possible.
A trigger can be invoked before or after the triggering event. The triggering event specifies before, after which operations on the table the trigger is executed. A single event is an insert, an update, or a delete, events which can be combined using the logical connective. If a trigger is used to maintain an integrity constraint, the triggering events typically correspond to the operations that can violate the integrity constraint. In a trigger, when clause can only be used in combination with a for each row trigger, the clause is used to further restrict when the trigger is executed. For the specification of the condition in the when clause, the same restrictions as for the check clause hold, altering, disabling, and enabling constraints. A constraint may be disabled at the time the table is created and then explicitly activated by the owner at a later time. This is useful for recursive relationships where a foreign key refers to the primary key of its own relation. Loading data would be impossible if the foreign key could not be switched off initially and then switched on after the table has been populated. It is important that data adhere to a predefined set of rules as determined by the database administrator or application developer. Enforcing business rules in the code of a database application. Using stored procedures to completely control access to data. Enforcing business rules with triggered stored database procedures. Declarative ease. When we define or alter a table, no additional programming is required. The SQL statements are easy to write and eliminate programming errors. Oracle controls their functionality. For these reasons, declarative integrity constraints are preferable to application code and database triggers. The declarative approach is also better than using stored procedures because the stored procedure solution to data integrity controls data access, but integrity constraints do not eliminate the flexibility of ad hoc data access. Integrity constraints are defined for tables, not an application, and are stored in the data dictionary. Any data entered by any application must adhere to the same integrity constraints associated with the table. By moving business rules from application code to centralized integrity constraints, the tables of a database are guaranteed to contain valid data no matter which database application manipulates the information. Stored procedures cannot provide the same advantage of centralized rules stored with a table. Database triggers can provide this benefit, but the complexity of implementation is far greater than the declarative approach used for integrity constraints. If a business rule enforced by an integrity constraint changes, then The administrator need only change that integrity constraint and all applications automatically adhere to the modified constraint. In contrast, if the business rules were enforced by the code of each database application, developers would have to modify all application source code and recompile, debug, and test the modified applications. Oracle stores specific information about each integrity constraint in the data dictionary. We can design database applications to use this information to provide immediate user feedback about integrity constraint violations even before Oracle executes and checks the SQL statement. The semantics of integrity constraint declarations are clearly defined and performance optimizations are implemented for each specific declarative rule. The Oracle Query Optimizer can use declarations to learn more about data to improve overall query performance. Also, taking integrity rules out of application code and database triggers guarantees that checks are only made when necessary. We can disable integrity constraints temporarily so that large amounts of data can be loaded without the overhead of constraint checking. When the data load is complete, we can easily enable the integrity constraints and we can automatically report any new rows that violate integrity constraints to a separate exceptions table. Summary. Now in the end, let us summarize what we have learnt in this lecture. The purpose of a referential constraint is to guarantee that table relationships are maintained and that data entry rules. Referential integrity is the state of a database in which all values of all foreign keys are valid. You can use primary key and foreign key constraints to define relationships between tables. The update rule of a referential constraint is specified when the referential constraint is defined. The choices are no action and restrict. The update rule applies when a row of the parent or a row of the dependent table is updated. The nullable columns of the foreign keys of any rows that are their dependents in a relationship with a delete rule of set null are set to the null value.